Okay, reflection and absorption of ultrasound. Why is this important? Because when we discussed the use of ultrasound in medical imaging, we talked about how waves can be reflected, right? And we were so interested in the reflected wave to determine how we can be able to diagnose these different images and all of that. So we have to be very careful and really analyze and understand what's happening with this reflected wave. But also, not all of these waves are going to be reflected. Some of them will be absorbed or transmitted or continue to move into the baby or into the structure being discovered or being observed using ultrasound. So for illustration purposes, we're going to have this diagram that sort of splits this as two different things. The first one is what we call the incident wave, right? So if a particular wave, a particular ultrasound that's coming is going to look like this, very much so, right? So if your incoming wave, which is entering, then it hits this boundary. Some of the wave is going to be reflected and some of it is going to be transmitted. And remember, if it hits like this, it's going to be reflected exactly like this, right? But we have sort of just drawn them like this so that we can be able to distinguish them easily without a lot of confusion for you guys. But don't think that it's going to enter like this and then it's going to be reflected like that. No, it has to return to the same detector. This is just for illustration purposes, right? So the reflected wave will therefore be reflected like this, that some of the wave is reflected back, but some of the wave will continue moving or will continue being transmitted into the muscle. So you have the incident wave, which is here, the incident wave. And then you have the reflected wave, okay, which is over here. And then you have the transmitted wave, which is over here. You can therefore see clearly that the incident wave should be equal to the reflected wave plus the transmitted wave. This is a very, very, very important equation that we're going to get back to, right? So the intensity wave, the incident wave is related to the reflected wave and the transmitted wave by that above equation. We can therefore use this where we say I represents the intensity. The intensity is just how powerful is it. It's a way of measuring how powerful a wave is. So the incident wave is going to be equal to the reflected wave plus the transmitted wave, right? So essentially, the incident wave that you have is going to be equal to the reflected wave plus the transmitted wave. So this is what we mean. It's a very, very short subtopic, but assume you have 100% of wave that is incident in a particular boundary, 20% of that wave will be reflected, and 80% would therefore be absorbed or continue to be transmitted into the tissue. So this is very important because, like I said, in ultrasound, we're concerned by the reflected wave, the wave that is reflected and gets back to the detector, so that we can be able to analyze that using our computer. And we are very concerned about reflection and absorption because we're interested in the reflected wave. So we need to know how it relates to the incident wave and how it relates to the wave that will be absorbed. The next video, we're going to be introducing a very new and cool concept. I'll catch you guys.